We now discuss the solution of a problem from the section Real Analysis. The problem is related to the properties of continuous functions. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022, and it is from the section C. The given question is, consider the following assertions. Assertion S1. E power cos t is not equal to e power 2022 times sin t for all t belongs to the open interval 0 to pi. Assertion S2. For each x greater than 0, there exists a t belongs to the open interval 0 comma x such that x is equal to log of 1 plus x e power t to the base e. Assertion S3. E power mod sin x is less than or equal to e power mod of x for all x belongs to the open interval -1 to +1. Which of the above assertions are correct? We are given four options. Option 1, only S1. Option 2, only S3. Option 3, only S1 and S2. Option 4, only S2 and S3. We are given three assertions, S1, S2, S3, and we have to discuss the validity of these three assertions and then answer which of them are true. Let us now consider the assertion S1. E power cos t not equal to e power 2022 sin t for all t belongs to the open interval 0 to pi. Is it true? That's the question. For that, we consider f of t is equal to e power cos t minus e power 2022 times sin t, t belongs to 0 to pi. Notice that this function f of t is continuous in the closed and bounded interval 0 to pi. Why? Because cos, sine are continuous functions, exponential is continuous, and the composition of continuous functions is again a continuous function, and the difference of any two continuous functions is again a continuous function. Therefore, f of t is continuous in the open interval 0 to pi, and we notice that f of 0 is equal to e power cos 0 minus e power 2022 times sin 0. E power cos 0 is 1, e power 1 is e minus e power sin 0 is 0, so e power 0 is 1. So e minus 1 is greater than 0 because e is greater than 1. F of pi is equal to e power cos pi minus e power 2022 times sin pi. Cos pi is minus 1, e power cos pi is e power minus 1 minus e power sin pi is 0, so e power 0 is 1. So e power minus 1 minus 1, e power minus 1 minus 1, which is less than 0. Yes, it is true. So by intermediate value theorem, there exists a c in the open interval 0 to pi such that f of c is equal to 0. That is, this implies e power cos c minus e power 2022 sin c is equal to 0. F of c is equal to 0. So that will imply e power cos c is equal to e power 2022 times sin c for some c in the open interval 0 to pi. So that means your assertion S1 is not true, is not true. So the assertion S1 says e power cos t is not equal to e power 2022 times sin t for all t belongs to 0 to pi. But here is a point c in the 0 to pi such that they are equal. They are equal. So, thus the assertion S1 is not true. We continue in the next slide for the assertion S2. So, this says for each x greater than 0, there exists a t belongs to the open interval 0 to x such that x is equal to log of 1 plus x e power t to the base e. So, as given, let us say x greater than 0. X is a positive real number arbitrarily chosen. Consider the interval, the open interval 0 comma x. Let f of y is equal to e power y. Y belongs to the open interval 0 to x. Agreed. Now, clearly, f of y is continuous in the closed and bound interval 0 to x because e power y is continuous everywhere, so also continuous in the closed and bound interval 0 to x. And f of y, e power y, is differentiable in the open interval 0 comma x. Thus, the conditions for the Lagrange's mean value theorem are satisfied. Therefore, we apply Lagrange's mean value theorem. Then it says there exists a t belongs to the open interval 0 comma x such that f of x minus f of 0 by x minus 0 is equal to f prime t. So, f of x minus f of 0 by x minus 0 is equal to f prime t. F of x is e power x, f of 0 is e power 0 by x is equal to f prime t is e power t only. Agreed. Cross multiply, we will get e power x minus 1 is equal to x e power t. That is equal to e power x is equal to 1 plus x e power t. So, that is x is equal to, take the logarithms on both sides, x is equal to log of 1 plus x e power t to the base e. Thus, for each x greater than 0, there exists a t belongs to the open interval 0 comma x such that x is equal to log of 1 plus x e to the power of t to the base e. Thus, the assertion S2 is true. We continue for the next assertion S3. S3. E power mod sin x is less than or equal to e power mod x for all x belongs to the open interval minus 1 to plus 1. It is known that mod of sin x is less than or equal to mod x for all x belongs to R. This fact may be seen from the graphs of mod sin x and mod x. It's very clear from the graphs of mod sin x and mod x. Let's see the graphs. So, this is the wave is y is equal to mod sin x and the v-shaped y is equal to mod x. And it shows mod sin x is less than or equal to mod x for all x belongs to R. Right. So, mod sin x is less than or equal to mod x for all x belongs to R. And this will imply e power mod sin x is less than or equal to e power mod x for all x belongs to R because e power x is an increasing function. Right. This is true for all x belongs to R. Therefore, this is also true for all x belongs to the open interval minus 1 to plus 1. Therefore, e power mod sin x is less than or equal to e power mod x for all x belongs to the open interval minus 1 to plus 1. Thus, the assertion S3 is also true. And so far, we have shown the assertion S1 is not true, the assertion S2 is true. Thus, the assertions S2 and S3 are true. Let's look at our options and our answer that assertions S2 and S3 are true appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of the problem from the section real analysis, which is related to the properties of continuous functions. It is definitely easy question. I am sure that you have understood the solution of this problem. and I wish you all the best. Thank you.